We're going there, and you're going to see a few videos we have and some people.
Okay, they just switched over the large display on these inflatable screens to the Jet Propulsion Laboratory in Pasadena, California.
All right, so here, once we get the audio going, this is John Rossinger. He's the chief scientist of our science lab.
In the middle is this way cool thing, and we have a picture of the ellipse that shows it. Mount Sharp, tell us about Mount Sharp.
Yeah, Mount Sharp is a really unique feature, and you can see it there in the graphic. And basically, from the landing ellipse up to the top of Mount Sharp is taller than the elevation of Mount Whitney, which is the largest mountain in the lower 48 states. And so we hope to land in the ellipse.
Mount Sharp is right in the middle of that crater. I'm going to point the laser at it. No, I'm not going to point the laser at it.
So Curiosity is going to be climbing Mount Sharp, but right where we are planning to land, there's some cool things there as well, some alluvial fans.
Yeah, this was a really great surprise. We know about it when we picked
So alluvial fans are actually flood material that's flowed as a result of water, large masses of water pushing material down slopes. And
it spreads out down.
There he's describing it now.
The blue colors are lower in elevation. The red colors are higher. And so ancient sedimentary materials were transported down right into our landing site. And so this gives us a really good chance, we think, of finding some evidence of water-rich environments right where we land.
So we can be exploring some really cool stuff very soon.
Yeah, we're excited about it for sure.
All right. Well, I'm going to let you get back into the control. I know you're really excited, and good luck to Curiosity. All right. And as we're hearing, landing on Mars is full of challenges. The same is true of communications during landing. It is a complex dance of celestial mechanics that has to take into account the positions of two planets, three spacecraft, all of which are in motion, going in different directions. Sound complicated? Well, it is. Here's a video to try to break it down into simple terms.
After 7 dramatic minutes of entry, descent, and landing, everyone will want to know, did Curiosity survive? There's a possibility we won't know, at least not right away. During its descent through the atmosphere, Curiosity must switch to a new antenna for each transformation it makes. At each switch, we could lose lock on the signal for a short time. That won't hurt the rover, it just means we won't know what's happening right away. Even with a solid signal, the communications link direct to Earth only works during the first half of the rover's descent. Why? Like Earth, Mars is spinning, and during landing, Curiosity and its landing site will disappear from view like the sun setting. Out of sight equals the end of direct radio contact. But NASA has 2 spacecraft orbiting Mars that can help. For the second half of Curiosity's descent, the Mars Odyssey orbiter is in a good place to pick up the rover's signal and send it right back to Earth. To best hear Curiosity's signal, Odyssey must rotate about an hour before landing. That sounds easy, but engineers are asking Odyssey to perform a maneuver it's never tried before. Will it work? Probably, but it's not a sure thing. If Odyssey doesn't rotate successfully, never fear, the rover won't be affected whatsoever. Once again, it just means we have to wait longer to hear from the rover. Odyssey could perform as hoped, but we're still not home free. Engineers always think of what if. For instance, what if the rover lands on a slope? If so, the low-flying Odyssey orbiter might not be able to pick up its signal. Even if everything goes according to plan with Odyssey, there's a final challenge. Time. The rover may be standing safe on Mars, but Odyssey has to be quick in getting the signal. Odyssey is moving fast. It will only be in the line of sight to hear from the rover for a few minutes, perhaps no more than 5. So the Mars reconnaissance rover plays the role of backup. It will also fly overhead, capture what happened, and then store the landing data it collects on board for playback to Earth a few hours later. Engineers then have to decode the data, which takes several hours. Sometime in the middle of the night for Curiosity's mission team, it's possible that the orbiter could tell us the rover's fate. Or there are other scenarios where the rover might be perfectly safe, but we might not hear from it for 3 days. That's all to say, Curiosity's landing is filled with drama, and will need lots of patience. No wonder they call this rocket science.
And you're watching live coverage of Curiosity's entry, descent, and landing on Mars. Mars, and we are a little more than an hour away from the projected time of Curiosity's landing. And no one knows how challenging this landing is going to be. Even Mars Science Laboratory project manager Pete Teisinger, Pete's been through this before, twice in fact, with Spirit and Opportunity.
Yeah.
So you know how intense this is going to be, and I guess we must remind the audience that even if Curiosity lands safely on Mars, there is a possibility that we may not know it.
That's true. We are reliant for Odyssey to give us full telemetry communication in a real-time, near real-time fashion for the very tail end of the descent landing. Back on Spirit and Opportunity, we had these Earth cones all the way to the surface. But on Curiosity, the landing site is below the horizon, it seems, or it is just set a couple minutes ahead, and so Curiosity will kind of follow the horizon just after parachute. So Odyssey is key for us right away, whether or not we've landed successfully.
We'll keep our fingers crossed. Now, a lot of people don't realize that Curiosity was built and tested right here at NASA's Jet Propulsion Laboratory, and we have pictures of Curiosity in the clean room the days that it was being packed up and sent off for launch. So a little faster than it really happened.
Just a couple of minutes faster, yes.
All right, so this gives you an idea of the rover and its size. You can see all the folks in their bunny suits and all the technology that went into this rover. And to give you an idea of some of the technology here, we brought on here to the desk a wheel of Curiosities.
Yes, you almost have to look through it, right? Oh, how are you?
It's quite large. And let's compare that to Spirit's wheel, and compare that to Sojourner's wheel.
In fact, if you look at Spirit, the bottom of the electronics enclosure on Spirit is right at the top of it of Curiosity's wheel.
Wow.
So, major step forward.
But this puts quickly into perspective what you're dealing with. This is an entirely different rover, which meant that you had to address it differently. Your landing had to be different. Your landing system.
That's right. Spirit Opportunity were giant geologists, rover geologists. We are now wanted to have a roving chemical laboratory, and that meant that the science instruments were much larger, much more complex, and much more sophisticated, and that the rover had to be larger. In addition, the scientists wanted it to last longer, so we had to design it to last 2 years rather than the 90 days for Spirit and Opportunity, even though they've lasted longer. And also, the scientists wanted to row further, 20 kilometers. And so, all those things put technological advance on the development. For the sampling, they also wanted to do sampling for the chemical instruments, and the sampling required a drill and processing of that sample. They wanted to go to better landing sites, so we could use guided entry so we could get it to a smaller ellipse. There are a large variety of technological achievements.
And speaking of that, because you had to think out of the box and think of a new way of landing this rover, you've come up with new technology, and the ellipse now, you can actually target things much better than previous missions. We have a graphic that shows a comparison of the ellipses.
Yeah, you can see on the graphic the size of the Pathfinder ellipse and how large it was, and the size of the Burr and the Phoenix ellipse, and then the size of the MSL ellipse. And the reason that's important is because you recognize that you want to be safe no matter where you land in the ellipse. And that meant that Pathfinder had to find a region that large that was safe for it to land. Clearly, Gale Crater would not be that. Even Murr, which landed at Gusev and Meridiani, you can see could not fit into the moat around Mount Sharp. As a result, even though at the time of Murr, Gale was considered a nice landing site, we did not have the landing system that allowed that to happen. Now with MSL, we have the guided entry, the sky crane approach, and you can see we're able to get right next to Mount Sharp, and that lovely sedimentary strata that John Grossinger is talking about.
Wow. So before you go, there's a big question. Everybody wants to know, will we see some pictures right after landing today?
Maybe. We do take a picture after we land, about 2 or 3 minutes, within 4 minutes after we land.
Are you from Ames?
And at that point, honestly, this very key communication link is just reaching over the horizon. And so it's possible that we are hopeful that we'll see
I was a support personnel on the Mars Exploration Rover, and Pete Theisinger, he was the lead manager on that project as well.
All right, thanks, Pete.
Who do you have to know to get into JPL for one of these things?
You're watching live
It depends on where you want to go. They have public areas just like they're having here, but if you know somebody, you can get a guest pass and get in. Yeah.
But you can also watch on the web at www.
But Pete Theisinger, yeah, they have something called an Entry, Descent, and Landing Readiness Review, and
in the days ahead,
they had that for the MSL, and they had it for the MER, the rovers that are still there.
www.jpl.nasa.gov/MSL.
It's a very tense time because the
right now,
software on board MER had some problems, and they actually had to make some last-minute modifications to it in order for it to land safely. So it was an amazing experience. There was a lot of talk and everything, and we finally had to say go or no go at the end.
10 p.m. Pacific, somewhere between 10 and 10:10 Pacific. Right now, navigation is giving a report on our current situation. So we can check in what happened here. But from what I can see, we're right on target.
JPL's had an outstandingly good